In this lesson, we're going to learn how to divide polynomials by long division. So consider the polynomial function f of x equals 6x cubed minus 25x squared plus 18x plus 9. Suppose we know that this function has a 0 at x equals 3. What else could we hypothesize about this polynomial? Well, if it has a 0 at x equals 3, I know that it has a factor which would be x minus 3. And if something is a factor, that means that it goes into it evenly. Or another way of stating that is that your remainder would be equal to 0 if I divided that function by x minus 3. It's going to be a key idea as we go through this. So before we look at the steps in polynomial long division, let me remind you of how you do simple numeric long division. You begin by asking yourself, how many times does 4 go into 6, which you know is 1 time? So then you multiply 1 by 4 to get 4, subtract, get 2, and bring down your next value. You repeat this algorithm, asking yourself, how many times does 4 go into 21 this time, which would be 5, and this value goes directly above this 1. 5 times 4 is 20. Subtract, you get 1, and you bring down your next value. 4 goes into 13 3 times, which is 12. Subtract, you get 1. Now, you learned to do this several ways back in elementary school. You first went remainder of 1, and then you did things like, oh, well, remainder of 1 means that we still have 1 divided by the divisor, 4th remaining. So 4 goes into 613, 153, and 1/4 times. Let's mimic this now with polynomial long division. We're told to factor 6x cubed minus 25x squared plus 18x plus 9, completely using long division if x minus 3 is a factor. Now, if x minus 3 is a factor, that means that it goes into it evenly, and that my remainder, there'll be nothing left over. I'll have a remainder of 0 if it's a factor. So what I do is I put my polynomial beneath the division house, and I make sure it's in standard form, meaning if I were missing any degree, so it goes 3, 2, 1 constant, if any were missing, I would need to put a 0 as a placeholder. I begin by asking myself, how many times does the leading coefficient x go into this leading coefficient, 6x cubed? If you struggle to understand what I mean, then off on the side, you just take those two and write it like this, and that would be 6x squared. So it goes in 6x squared times. Now notice that I wrote that directly above the other x squared term. That's my preferred way of doing it. It helps me keep everything aligned when I line up like terms. So now I multiply. 6x squared times x minus 3 produces 6x cubed minus 24, excuse me, not 24, that was brilliant, 18x squared. Now the next step is to subtract in my long division algorithm. I do that by changing the signs on the bottom row. In other words, distributing my minus sign, and now it's addition. These first two cancel. They will always cancel, or you've made a mistake. Next, I would have negative 25x squared plus 18x squared would be negative 7x squared, and I bring down the 18x. I repeat my algorithm. I ask myself, okay, so how many times does x go into this negative 7x squared? That's going to go in negative 7x times. So I put negative 7x above that 18x where it's like. Repeat the multiplication step. Multiply, this will be negative 7x squared plus 21x. And looking back, I realize I didn't bring down that x. Now, I'm going to change my signs because I'm subtracting. And now I'll add. First two cancel. Positive 18 minus 21x is negative 3x. Bring down the final plus 9, and I check how many times does x go into negative 3x. It's going to go in negative 3 times, so I put a minus 3 here. One final multiplication produces negative 3x plus 9. Final step, to subtract means change my signs and add, and I get 0, which I knew from the start I should because my remainder was going to be 0 because x minus 3 is a factor. Now, so first I did my long division. Now I need to do, I need to factor this remaining polynomial because I need to factor completely. So far I know that the original polynomial is equal to x minus 3 times 6x squared minus 7x minus 3. And this polynomial potentially factors further. So I'm going to bring down the x minus 3, and you need to factor that by the method of your choice, whether it be guess and check, or those of you who use the tic-tac-toe method. And when I factor this, I get 2x minus 3 and 3x plus 1. And now that cubic function is completely factored. In our second example, we are just told to divide. We are not told to factor completely. So perhaps this goes in evenly, or perhaps it's going to have a remainder. Now here's what I noticed, that in this one, I'm missing an x squared term. So I'm going to just put this placeholder of plus 0x squared, and then I have minus x minus 3, and I put my divisor out front here, the 3x plus 2. Again, I begin by asking myself, what is 9x cubed divided by 3x, or how many times does it go into it? And that would be 3x squared times. So I write that above my 0x squared, and now I multiply. 3x squared times 3x is 9x cubed. 3x squared times 2 is plus 6x squared. Now I need to subtract. So I change the signs on the second row, and I add. Gives me negative 6x squared, and I bring down the negative x. Repeat, how many times does 3x go into negative 6x squared? And that will go in negative 2x times. So I put my negative 2x up here, and I distribute, and that gives me negative 6x squared minus 4x. I need to now change my signs and then add, which is the same as subtracting. This gives me 3x, bring down my negative 3. And how many times does 3x go into 3x? That goes in just one time. Multiply, and I'm going to have a remainder this time. Change my signs, remainder of negative 5. So rather than putting r of negative 5 like you did back in elementary school, what we're going to do is write this as a fraction. So this would be, you can either put plus negative 5 over the divisor, 3x plus 2, like this, or you'll also see it as minus 5 over 3x plus 2. The final one, we're going to be dividing by a trinomial. I make sure in my dividend that I do not have any missing terms. I also check the same in my divisor. All right, so we're going to do 2x to the 4th divided by x squared. That's going to go in 2x squared times. So I'm going to put that directly above this term. And now I'm going to multiply 2x squared times the divisor, producing 2x to the 4th minus 4x cubed plus 14x squared. Now, change it to subtraction, which means I'm changing my signs in the bottom row, and I'm adding. This term would cancel, and I get negative 1x squared. Now you notice how 2 terms crossed out there. So it's like I just skipped a whole step in my algorithm. So what I'm going to do is bring down the next 2 terms rather. And now I'm just going to pick up here and say, okay, so how many times does x squared go into negative 1x squared? It's going to go in just negative 1 time. And multiply, that produces negative 1x squared plus 2x minus 7. Now I subtract, meaning I change all my signs on the bottom row, which produces 1x minus 4 for my remainder. So I'm going to again write this as plus my remainder, x minus 4, over my divisor. So here is my answer, and I just rewrote it there on the screen for you to see.